Small board computers, also known as single board computers, have gained popularity in recent years due to their affordability, versatility, and ease of use. These miniature computing devices can perform a wide range of functions, from running a media center to controlling your home automation systems. One of the most well-known SBCs is the Raspberry Pi, which is built on the ARM architecture and has become a favorite among hobbyists, educators, and makers alike. The Raspberry Pi is highly customizable and can be used for a variety of purposes, including programming in general, robotics, and even music creation. In this era of digital transformation, as SBCs like the Raspberry Pi have proven to be powerful tools for learning, experimentation, and innovation. Raspberry Pi usually is meant to boot an operating system like Linux. But as some of you might already know, you can also program these like you would normally program a microcontroller, such as an Arduino board or an ASP32. That also is known as Baremetal Programming, hinting that there's no operating system underneath your code running. This usually means that your embedded application will start faster, will behave more consistent over time, and most importantly, your SD card will last a very long time because only your application will write to it if you need it and when you need it. Today, I will present you the easiest way to accomplish bare metal programming on the Raspberry Pi, all within Visual Studio Code with IntelliSense code completion. I will walk you through some required installation steps to have your environment ready. So we will install Chocolatey, a package manager for Windows, Git Bash, and VS Code. With Choco, we will install wget and make. Let's begin. Let's open up the browser, search for Chocolatey. Let's click on Try Now. This will get you to a page where you get to copy this text that you will be able to paste it in a Windows PowerShell run as administrator. This will grab Chocolatey and install it on your computer. Enter. Now that we have Chocolatey installed, we can try it. It works. Let's already install, as we already know, we need wget. And yeah, okay. Let's install make also, because we will need it. Okay. Yeah, it's installed, it's working. We don't need Chocolatey anymore. Now let's grab Git Bash. I will link you down below all your links needed. Okay. For the most part, we need Git installed with the default parameters. Yeah, pay attention on this option. Mostly, I think it's all defaults. Let's launch it. Try a few things like make Git. It works here. Get doesn't work. Let's try restarting the terminal. Yeah, it works. Let's try in Git Bash too. Yeah, it works. Now, what else? We need to clone the environment for the Baremetal programming, which is called Circle. So grab the link. Let's create a folder in our documents. Let's name it embedded. Raspberry Pi or embedded dev. Let's embedded dev. Can now let's zoom in a bit. Git clone with recursive. The link that you grabbed. This will also download all the submodules that this repository has, such as LVGL and some WLAN for wireless host AP. There are some modules. Let's see the Windows documentation. So we now need the toolchain. Oh, we had to make. We need the toolchain for ARM. We will use it. We will download the Windows one. We don't need any complications. We don't intend to install Linux virtual machine or anything. We're just gonna use this Windows for developing and compiling and everything, and also pushing the images towards the Raspberry Pi. Should be. We don't need these from the documentation. Paths are already set by the installation. Okay, let's add this path also to the environment variable for the toolchain. And we can also try it out. Let's see on this one because it has to update the path. That's another one. Here, for example, I can remember the name, the prefix for the toolchain. Let's see, ARM none EAB. Let's grab this as a prefix and G++. Okay, so it works. Paths are updated. Let's move on to Circle and do a configure for Raspberry Pi 3, 32 bits, and make all. The J. So let's type -J to use all the cores available. Finalized. So now we have the toolchain compiled with all the samples. Not all the samples, only the toolchain, the libraries. Now let's see this a sample, like just test it out if it works. So it compiles. As you can see, it spit out this kernel image, which you can put on your SD card together with some other files, and it will just put into the application that it was compiled. Let's see LVGL. This is a bigger. Keep pressing wrong buttons. This is quite a big project. It's a graphical library for user interfaces. It doesn't have a Mac file. Yeah, here it is. This will take quite a bit longer. Compiling some objects from examples from the library. And it's done. Now let's see the sample folder, which has a sample for us for the circle library, and it compiled right away. What else do we need? Now let's configure. Now let's download VSCode first, because we need to do this programming while being comfortable, right? Install Visual Studio Code. Default options, nothing special. And this is my secret sauce. Up until now, things were standard. Most of you already knew how to use directly circle and compile, but we want more. We want to use this library with VS Code. So let's open a folder from the samples directory in circle. Like let's screen test something. Screen, no, okay. Yeah, the third one. Let's select the folder. Okay, I trust the authors. I don't care about this right now. So this is our sample, the screen text. It includes some header files from the Circle library. Okay, let's install that. We need the C++ extension pack for our IntelliSense, especially code completion. Okay. Let's configure the JSON. Now, here we need to set the include path for the library. So IntelliSense will be able to find the header files. So it can help us out when writing the code. Here, it's already including the workspace folder, which is fine, but we also need to paste in. Let's grab it first. The whole URL. So here, the header files, right? And paste it in, but I don't think this will work. Cut the last circle and yeah, use tilde document. We need to use the Unix format for paths here, and I think this is should be fine. We can. Well, no, I think this is okay. So this is a C++ properties JSON. Okay, so now it's telling me there's a quick fix for this, but it should have been a problem anymore. Oh, okay, let's first add the configuration, name it ARM, because it's not Win32. It doesn't matter, just for completion's sake. Okay. ARM32. Now things should be fine. We should get code completion. Okay, you can see it's fine now. Let's see. Yeah, we have auto completion. Nice. Good. Let's change this. Let's have show off the arguments. Good. Now we've pretty much finished with this JSON. Let's create another one. So this C++ properties is only for VSCode to understand, to get header files and help you out. Now, in settings JSON, we need to update your default terminal from PowerShell to Git Bash. Just type whatever I'm typing. I will also have it linked in a GitHub. So typing in integrated profiles .windows will autocomplete you with these options. We only need Git Bash. So let's add first the path for this. Path, let's see, where is it? Let's not guess. Program file. No. Okay, let's find it. Program files. I think it's 64-bit. Don't remember. Yeah. So here it is. gitbash.exe. We have the path C program files git. Oh, okay. Let's grab it. Paste it. We'll use double slashes here. And gitbash.exe. This is the path for gitbash, and we'll just delete everything else. We don't need PowerShell. And also command prompt. I think this is it with this file. No, okay. Yeah, we also need to declare the default profile for our operating system, which is Windows, as Git Bash. Otherwise, it will also try PowerShell even if it's not declared, and it will just error out. Good. Now, yeah, so it works. If you click on terminal now, it's Git Bash. It's not PowerShell anymore. Trying out making the project works. Good. Now now we need one more thing to make our lives much easier. Any integrated development environment that respects itself has a build option, a compile option at least. Let's do that. Let's create configure a task. Create tasks JSON from template and select others. It will pre-populate it with this, which we don't need. Replace label with let's say clean for now. It's a shell command, and the command is make clean. Next, okay, so this is from group kind. Okay, I'm struggling. Kind. Let's say clean. It will give you a warning because it's not one of those things that it recognizes, but it will still work. So now this is our clean task. See, this is a warning, it's not accepted, but it will still work. Don't worry. Okay, now let's say another task, like build or yeah. Compile, I think, no, build, because it uses the make files. Type, yeah, still shell. A command make. Now the group is kind build and default. I think this is it. Yeah, it's pretty much it. Don't worry about this. Okay, have the settings, the CSS properties, and now we can test things by Control Shift B. Pressing Control Shift B runs the build task, and you can see it's working. It's building the kernel image. Let's try and let's see. Let's modify this value, for example, and rebuild it. Yeah, it will correctly rebuild it. Good. It works. So it seems that I missed something. This shouldn't be here. Delete this. We only need the first part, ARM32. Delete this. Right on this. Another folder fractal. Filed perfectly fine. Clean. Rebuild it. Pretty fast. Now great. After you've finished programming, grab the kernel file resulted from compilation together with the files from boot subfolder in the circle environment, which are various firmware support files, and put them on a FAT32 partition on an SD card. Boot your Pi with it, and that's it. Enjoy it. In my next video, I will also tackle uploading directly from VSCode after building by using a serial interface so you can truly program like you would a microcontroller. It will upload only onto RAM, but it will be very helpful anyway for fast iteration and debugging. Goodbye for now, and take care.